Hey YouTube, Kimber here. Just got my thread dial reinstalled and my half nut lever engagement situation improved. I think corrected might be the right term. By the way, I'm Kimber and welcome to my channel. I am a self-proclaimed student machinist. I learned machining by watching others on YouTube, and I emulate what they do with the tools that I have. There's a couple of things about the mini lathe itself. I've now had a mini lathe for just over a year, and there are things that are just not occurring to me. On the back of my machine, there is a lever that engages the direction of the lead screw. The lead screw is what moves the carriage left and right on the ways for power feeding. I didn't always understand that at first because I have a reverse switch. I can just hit the reverse switch and go backwards. And then there's a third position, which is neutral. And I have not, till recently, I have not utilized neutral. If you're not engaging the power feed, there's no need to run all those gears. So in neutral, you're basically running the motor to the belt to the spindle, and you're leaving all those gears idle, which is going to add to their life. So just a small thing that just occurred to me after a year scratching metal on this thing. And another thing that I find myself doing is not really defining what it is I'm doing. By doing that, I'm not committed to anything, and you make much fewer mistakes. You don't make as many mistakes if you don't have a plan. If you repeat a mistake, it just becomes a new program. So Fusion 360, which is a computer-aided drafting program, I guess, has a free version for hobbyists. And a person could get on there and draw up plans and have a very professional looking plan, as well as a record of what you've built to reference in the future if you need to. Yeah. Also, with the plan, you can develop an order of operation, which is kind of thinking through the problems that may occur in the process of creating your part. There's been more than one occasion where I finish one end of a piece of material and I want to flip it over and machine the other, but I don't have enough stock on my material to do that. And I end up having to build some kind of fixture and modify things, which takes time. And for me, that's fine because it's all a learning experience. Okay, I dropped a few things in evaporust in our last video, and let me show you the result. These things were not horrible, but what we got here is, I'm not sure what this is going to be called. Okay, that's a knurled thingy with a hole in it and a nice radius on the top, and it's 27/32. And this one actually has a tool maker's mark on it. And you know what that is that you find a piece of material and you want 27/32, you want to check it and test it. That would be your that would be the avenue to take. And here's another one. It has it looks like an AO on it, and it's 13/32, and it's got, again, the radius there. And here's some that are slightly different looking. There's a nice chamfer on one end. There's a nice radius going in, and that's a 1/4 inch. And that one says, no, I think it's 052-8 1/4. But once again, that's, you know, to check whether or not something is truly a 1/4 inch or not. So, some toolbox finds. And then I got these locking nuts. And here's a nice small one. An example of how I might use it as a drill guide, as a depth gauge on a drill. As long as you're not, you know, hammering the cutting edge of your drill with that screw. And while I have your attention here, we also have an idea I picked up here from, I think I got it from Joe Pye, where if you're going to be using a V-block on something with a shoulder, you got this triangular piece that'll, well, you get the idea. Either like that or vice versa. And then I found a half circle piece here that I think might work the same way as well. This one has 2 different dimensions and a taper. So we talked a little bit about CAD, or Fusion 360, and you know, it might look something like this, you know, only printed on your computer printer and looking much better. You know, there's always some information down here in the corner, and a picture, an illustration of your part, and all your dimensions, and this is our next project. I'm going to call it the impossible nut. And obviously, we're going to cut this in half, drill and tap each end, thread it back together, cut your threads, spin it off, spin the nut on, reconnect it, and it'll be an impossible nut. There's no way to see how that nut, you got it. So I got all these little numbers written down here, major and minor and drill size, and I get all that information here in the engineer's black book. There are different editions. This is the 3rd inch. But decimal equivalents, thread forms, this I use, I probably use this the most. There's a Unified National course, and use your quarter 20 or 5/16 18, and all the information that you need as far as what size drill bit you need, and on and on. And then there's lots more. There's countersink holes, screws and bolts, triangle formulas, angle conversion, tapers, keys, keyways, gears, workshop metals, plastic adhesives, coated, carbide insert identification, carbide holders. Lots of information there for the novelist. And there's some areas in this book that I'll probably never access. There's a difference between a machinist and a guy like me out in his garage imitating a machinist. I may never be that guy because people spend their entire life becoming a machinist, and I'm getting rather late start. But man, am I having fun. So hang around with me, and we'll try to make, there's a nice index. I've never really noticed. I've never used the index. There's a place for notes, a little graph paper. I'm discovering all kinds of new things. Okay. Okay, like I said, we'll get some things put away here and start thinking about our order of operation or plan of attack on our impossible nut. Enjoy the video. Well, I've certainly made a mess of things here. I got a lot of movement here. I'm going to need to go ahead and tighten these gibs up like all the way, because this thing's moving. This thing's moving 10,000ths of an inch. Every time it engages. instead of taking the cut, it's just pushing the tool back. See that? Watch here. Okay, we're going to get rid of this compound. Let's see what a difference it makes. Okay, I came up with a way of indexing on my lathe, and I have my hand crank with the protractor on it, and I found this little pointer in a toolbox, and I can mount that right up there, and I can use the protractor on the back of my hand crank to mark my locations, index around to the diameter of a part. Kind of a poor man's version. I found this little, what appears to be an acorn nut at work. A little damaged, but it has a nut inside of it as well. And that's a metric 4mm, and it gets a little tight here at the end. And then there's that on the inside. So I imagine that goes like that. But you know, I can't resist picking up shiny things. And I think what I'll do is try to replicate that as a little project. Maybe not the insert, but at least the external and internal and external threads and the domed acorn nut. And I have another thing here that I keep forgetting to talk about. And I'm just going to give you a good view of it. At first I thought it might be carbide, but I don't know. It has the weight, but I was able to get a file, mark it on a file with a file, and I'm not sure if that's a true test or not. It does kind of have the color, but is that a drill? A reamer? My guess it's a reamer, some kind. Another little item I found is a Loctite adhesive product selector. And you set the arrow at typical application. So locking and sealing screws, low strength, all the way to weld beads, castings. Sealing pipe threads and fittings, locking, sealing studs over 1 inch, up to 1 inch, pre-assemble screws and nuts. So, green, white, red, green, red, blue, purple. All the colors of Loctite I've never seen. There's viscosity information, gap felling, tensile strength, shear strength, temperature ranges, curing times. Okay, handy little reference. Okay, we got rid of the compound. We got this, I'm calling it my rigidity block. I don't know what you'd call it. But, vast improvement. Let's see what this difference is here. There's 354. We'll call it 350. And there's 425, 426, 350, 26, that's 75 thousandths shoulder there. There's about 700 RPM. And 75 thousandths is probably more than I should be biting off. But let's back off and take about half of that. Just trying to demonstrate the difference between using the compound and not. Let's see what this cut is here. Okay, we have there's 425, 435, 325, 35, 45, 345. Okay, 345. There's 435, 35. So it's 100 thousandths, I guess. It's 3, 25, 35, 45, 345. 425, 435. So there's 100 thousandths shoulder. I wasn't able to do a quarter of this with that compound attached. Now there may be other factors in play that had me crashing so violently. So I'm going to plunge in here. $20,000. And we have a rigidity. The rigidity issue there is in the material holding. So let me pull half of that back. 5 minus 7. This should be 12,000. Not, but really not happy with any of this. I mean, I have the rigidity back, but maybe this cutter is just not a good cutter for what I'm dealing with here. Let's get something that I'm used to here. Let me go ahead and get this height set. We'll just do it down and dirty here and see what we come up with. I can live with that. Okay, so we're tight there. Okay, that's clearly just okay, let's see what the difference is right here. So we're still at 425, 435, 445. Call that 445, and there's 220. 220, 420, there's 200,000, 200 and so this is 220,000 here. And then here's an interrupted cut on the end. Okay, that's all the travel I have. Okay, we'll just call that a demonstration in rigidity. We'll get back to our original project here real soon.